Okay, let's begin our third topic amongst these list of advanced topics that we were planning to cover for this class, and that's database security. I don't think I need to impress on anyone in the class about the importance of data security, particularly in today's world when all kinds of users, people have access to the internet through which they can get at the database. Loss of data results in a lot of monetary losses for businesses. So I will not, get into the reasons behind why database security is important. But the concept is very simple. Implementing it is quite difficult. Database security basically is the prevention of unauthorized access to a database. It doesn't mean not letting anyone get at the database, only people who are not authorized to access the database, not to get at them. Now, if you think about it, when we say unauthorized access, you don't divide users into just two categories, like those who are authorized to access the database and those who aren't. Okay, that's a simple categorization. But even among the people who are authorized to access the database, it's almost always the case that not all users are authorized to access everything. Okay, and by access also there are different categories of access. So you can have look access. You can look at information. You might be given access to information just to look at it. You may be given access to information to look at it and change it. You may be given access to add information. Okay, so for instance, adding a new employee to an HR database, to a university database, for example, that right may only belong to certain people in the HR department of the university. Maybe even a dean cannot insert a new faculty record or a new student record. On the other hand, changing a student's grade or reporting a grade, a faculty member may have access to a student's grade for a course simply to enter a grade. But once the grade has been reported, maybe somebody else only has the authority to change the grade. So you can see that even amongst people who are authorized to use and access the database, there are different levels of authorization also. So this whole business of security is quite complicated. It's not just a matter of who's allowed and who's not allowed. So if you can think about it, you have people and then who are authorized and who are not authorized. And these include people who are actively trying to get into the database also. So you have to keep all these people out of the database. Now these people can get in or are allowed to get in, but they have different levels of access. Some people only allowed to look, some people only allowed to update, some people allowed to insert, some other people may be allowed to delete only. So there are different levels of access that one can have, even when one is authorized to access the database. So security is a very complex concept, and it has complex dimensions to it, and it falls under the purview of database administration as well. The DBA has to ensure the security of the database. Now, in terms of giving rights to an end user, it's usually done through the grant and revoke commands. So you grant access rights to an end user. For instance, you can say grant, select, insert on this particular table. So you have a part table to this particular user. Okay, and then when you want to take it away, you can say revoke, insert on the same table from the same end user. So revoke and grant are two specific commands, and these are part of the repertoire of SQL commands that we did not cover in detail in class. We only did sort of select, update, and insert for records in a database. But these are access privileges, and they're typically done through grant or revoke. Okay, now in our discussion today here, there are many different mechanisms to enforce security, and obviously in 5 or 10 minutes or 15 minutes we can't cover them all. Given that we have studied SQL in the earlier parts of the course, we will focus on one particular mechanism among several that are there. We'll focus on one particular mechanism to achieve database security, and that's the concept of user views. Okay, so views, as I think I mentioned in the very first tutorial for this topic, that a view essentially is a subset of the database that an end user gets to see. Okay, so it's an individual user's picture of a table or a set of tables. So your database may have 15, 16 different relations in it. So an end user, through a view, think of it as a special window, and through this window, I'm just making the example up through this, but this window is designed in such a way that the end user can only see these two tables, let's say. Then you have automatically protected the database from these two tables. If the end user cannot even see these two, then it's unlikely that they will try to hack. I mean, they could try to hack into it, but inadvertently they will not try to access it and change things in it. So this concept of a view automatically provides protection by hiding certain portions of the database from end users. And this is intentional hiding, because the idea is that the end user doesn't need to see what is not in their view. Okay, so views typically include less information than the full database, and the way they are set up is through a create view command. So remember, when we were studying SQL, we had two types of SQL commands. We had DDL and DML commands. So create, and among the DDL commands, we had a create table, command. So here you have create view, and if you look at the syntax, it's very similar to a create table command. So create view, you give the name of the view, and then you give your names of columns that you're selecting, and then you have from where. So think of a view. So these tables that you're seeing in the from part, these are what are called base tables. So if I go back to my earlier picture, so I create the view from underlying tables. So I somehow combine the underlying tables in a way that creates an image to the end user of a view of another table. Okay, so let's look at some. So here's an example. Create view Brazil customers. So these are only customers from Brazil, as select customer name, contact name from customers where country is equal to Brazil. So based on what you know about SQL, you know that these three lines, select customer name, contact name from customer where country equal Brazil, you have a base file called customers, and that presumably has a lot of columns in it, and it presumably has customers from all kinds of different countries. And by using this particular select SQL command, what you're doing is you're picking out just two columns, customer name and contact name, and you're only picking out those rows for which the country is Brazil. So you're creating a subset of this base table. Okay, and this is the subset that the end user will see. So the end user will imagine that the database consists of just this one table which has customers from Brazil. And by setting up this view, you're automatically protecting the database, other parts of the database, from the end user, because the end user is not getting to see it at all. Okay, so this is a view. This is just an example in telling in words what I just described for you, how the table is created, how the view is created based on an underlying table. So a view acts as a window into the database. Views can have columns, and you can rename the columns, all of those things. But basically, it's taking one or more underlying tables and combining them using SQL to create a new table, which is your view. So think of a view as the result of an SQL query. The only difference is when you write an SQL command, the extraction is done, you see the results, and as soon as you finish the SQL command, the result goes away. Here, when you do a create view, the database management system will actually come back and create this table and store it for the end user to use. Okay, so there's a permanency to a view that is not there in just the the SQL command. So here is another more detailed example of creation of a view. So you're creating a view called REPCUST, okay, and it is created from two underlying tables, representative and customer, I suppose. I don't know what REP stands for. So you have certain columns that are pulled out from the different tables, from these two different tables, and they're combined using this join operation, okay, and the end user only sees one table that has one column, 2, 3, 4, 5, 6, so 6 columns in the output. So the end user sees one column which has, or rather one table which has 1, 2, 3, 4, 5, 6, 6 columns in it, and the end user thinks that this is what the database consists of, that the database consists of only one table. The end user is unaware that there are two tables hiding underneath that one table, okay, and that's how the view provides a certain level of protection. It's a security mechanism that one can use. It's a mechanism that one can use to achieve security in the database. But this is not the only one. There are a whole host of other mechanisms that play a role in achieving database security. Let me end this particular discussion by talking a little bit about indexes. I think I mentioned what indexes do. Indexes are like the indexes at the back of a book. So if you think of your textbook, in the last few pages you have a list of keywords, and next to each keyword you have a bunch of pages where this keyword appears. So if you are looking for a particular topic, you hunt down the list of topics, find the page number, and then go to the book. Okay, so it's just like an index at the back of a book. So it's the same story here. So indexes, they just help you search a table more efficiently. So the example that I gave you was, let's say you have an airline reservation table with lots of columns. So you have the reservation number, let's call our number. Then you have the passenger's first name, passenger's last name, origin city, destination city, the price of the ticket, departure time, arrival time, all kinds of information, okay? So let's say a customer comes in and wants to retrieve their ticket. So a ticket for a customer is one of these rows, okay? But most passengers don't remember their reservation number. We keep talking about primary keys and all those things, but they don't mean anything to an end user. So they might remember their date on which they are traveling and the origin and destination city. So you might want to search for their airline ticket based on date, origin, and destination. So you have to create indexes on these columns. So all the records for the same date are pointed to. So you have date, let's say 20th of May 2020. So all the records that are for flights on 20th May 2020, they would be pointed to. So all the record numbers would be here. So it would say, and end users don't see the index. They just say, I'm looking for my flight on the 20th of May. So the index has a list saying, okay, this is record number 400, record number 562, record number 634. These are different passengers who booked flights for 20th May. Do you see that this looks very much like an index at the back of a book? This is your topic, and these are the pages on which those topics can be found. So it's the same idea behind an index, okay? And the way indexes are set up is, again, there are SQL commands that can help you do that. This is the create index command. So you say create index, give the index a name, just like you give names to constraints when you're using SQL. So you have create index, give the name of the index, and then you give the names of the columns on which the index is created. So here's an example of an index called index last name that's created on the column called last name. So if you have a customer relation with first name and last name, if you create an index on last name, it simply means that all the records which have the same last name, so all the Smiths, so the index would say Smith shows up in record number 62, in record number 121, in record number 344, in record number 345. So think of these record numbers as pages in a book. So if Smith comes in and says, I want to find my record, and gives his last name, so then the database could just look at this index and say, oh, Smith is in one of these pages, so it just looks up those pages one after the other, and you save time by not having to search through the whole table. So the idea of a database index is very similar to an index in a textbook. It's just that you can create a whole variety of sophisticated indexes on a table. The nice thing about an index is that it speeds up searching for content in the database, but the price you pay for having an index is whenever you make an update to the database, then the indexes have to be updated also. So you can think of the following. Here's your main table, the relation, and then you have all these indexes that are pointing to different records in the table. So if any of the content in this table changes, you have to go back and change the indexes as well. So the analogy that I can give is you have a textbook with the indexes at the back of the textbook. If you change, let's say, some sections in the textbook, you have to go back and change the indexes because the page numbers on which these topics now show up will change as a result of you having changed the textbook. It's the same thing here. This is like your textbook. So if the textbook makes any changes, then the page numbers where content shows up will change. You have to go back and change the indexes as well. So updates take a lot longer when tables are heavily indexed. Okay, so that sort of wraps up the set of topics, that advanced topics that I wanted to cover. So just for your summary, 3 major topics that we covered. One was database administration, the second was concurrency control, and the third was security. And we had a brief discussion on what indexes are in a database. So these just sort of to whet your appetite on more advanced topics that you would run into if you follow up with another course on database management following this current one.